Today on AI Actually, loops versus graphs. What these AI agent design patterns mean for your business.
What's a loop? How do I use it? How do I think about it? If the agent is writing them themselves, you've got a loop. If you're writing, the human is in there creating the edges ahead of time, then you're creating a quote graph instead.
Loop engineering and graph engineering are not competing frameworks. You're very often going to have loops running inside of this broader framework, which is put together inside of a graph.
It doesn't create a need for fewer humans. In fact, I think it creates a need for more human labor.
Hey guys, this group has not been together in a while, but I thought I'd bring us together. There's this one topic. I'm going to try to just bring up this one slide that I thought might be, it's interesting to us, I know, and I think it might be interesting to other folks that we work with. And Peter Steinberger, who, if you don't know, founded OpenClaw, now I think owned by or sponsored by OpenAI, and he just put out this tweet that are we still talking loops? Should we shift to graphs yet? Got 3 million views, almost as many as I get when I tweet things like this, and of course it created quite a storm of other X posts and YouTube videos and so on. So I thought this would be, the space is moving so fast. I thought, this would be an interesting topic, right? 6 months ago, it was all about, loops. You remember the Ralph Wiggum loop, right? And, all these sorts of things. And so all of a sudden we talked about context engineering and loop engineering and now graph engineering. And I just thought it'd be a really interesting topic to cover with this group. I know is knee deep in all the above. So before we build out some AI org chart, I figured, maybe we'll talk about, how these things work. So maybe the first thing to answer is, well, first of all, I didn't even know what a loop was, right? So what's a loop? How do I use it? How do I think about it? Who wants to take that first one?
I'll throw something out there, which is that a loop is a type of graph. It's a proper subset, right? We talk about like DAGs a lot, acyclic graphs, but a loop is just a directed cyclic graph. It's nothing that is so different or special. It's a different way of thinking about, in this context, where are we going to let the model and the non-determinism of that model live? Are we going to say the model controls that? And that's pretty much what the looping piece was. Or are we going to put some more structure around it that controls it? And that's what people are referring to as graphs now.
And for the business person in the audience, help me come back to what's a loop. And
the way I would think of it is, we've been talking about, tires and engines and pickup trucks, right? That's the various parts of an AI system from a kind of abstract level. And now somebody's said, oh no, it's not just pickup trucks. It can be semi-tractor trailers. It can be sports cars, right? So the graphs, as Shanti is saying, they are. What we've been doing is a graph. It's just a specific kind of graph, right?
Why would people use loops? Like, what was a loop for, and why was it different, and like how would I use it? And
it's a very utilitarian approach that basically is like the Ralph Wiggum embodied. You just said if the AI didn't finish, then keep trying. You just tell it to try again and try again and try again, right? That was the classic loop. And then the question is, how do you break out of that loop, because it can't go on forever? Do you break out on time or budget? Do you break out when the job's done? How do you know the job's done, right? So these loops got a sort of a life of their own, and that's what we called an agent, right? We called it an agent when you could run a loop and it would intelligently stop at a good point, and it would finish a job, and it would record its history and all that, right? Now, stepping back a point from there, though, what we realize is, well, the reason we liked agents is because they could do things that weren't well defined upfront. You could say, go figure out the problem, and it would stay in a loop, trying again until it got it. But then the thing is, some things that we want AI to do aren't go figure it out problems, right? We want it to use specific sources. We want it to record what it did. We want it to verify the results it got. So that's more like a graph, right? That's more like a specific way of doing things that might contain some loops, but it's an overall structure that would be a graph.
And I keep trying to bring it back to, like, what's a business example of a loop? Like, if I'm in finance, like, what would I use a loop for? Like, what?
I think it's probably best. I'll try to explain a loop and a graph, maybe going back to more human terms, if you think of it that way, right? So imagine a loop is like one of your people in finance, right? Hey, go create this spreadsheet for me that does A, B, and C, right? And there's what the difference between the loop and the tradition and the pre-loop approach, which is where, you put in a prompt and it runs for a period of time and it tries to achieve that effort.
Right. Here's your spreadsheet.
Stops.
Yeah.
It'll just keep iterating until whatever exit criteria you define are done. Right. And we'll keep working on that spreadsheet. So let's say I'm an analyst, I'm a financial analyst. My goal is to create that spreadsheet. I'm in a loop working on the spreadsheet until, whatever criteria I had in my head or standard.
I finally got to the thing that produces the output I want.
Goal. I have something good enough now to share with others. Think of now what a graph starts to enable is a little more of almost like an org chart kind of view, right? So think about this now as you're putting much more discrete boundaries around certain types of activities. And you're saying inside of that activity, I'm going to have an agent do this work. But there's a handoff mechanism and approach where I can hand off to another agent that can do other work, other sorts of things in that regard. But that's kind of the graph versus the org, right? And so now a graph might be like, oh, my whole process for putting together the spreadsheet is not just me, the analyst, creating the spreadsheet. It's then it gets sent to, someone else who's a designer and makes the spreadsheet pretty. And then it gets sent to someone else who's, a really meticulous
to certify the facts, right?
Make sure everything is fine. And then it gets sent to my boss who looks at this from a certain angle. And then it gets sent to someone who's looking at it from a client. So you can build a kind of a whole structure around what it takes to really get that deliverable put together at a holistic level and with clear boundaries between who's responsible for what. It's just in this case, instead of the who being a human, it's an agent. Although you can have graphs that include human in the loop checkpoints, which is we'll get back to, I'm sure, but is one of the advantages of a graph is it can.
Yeah, I like all these analogies a lot. The accounting analogy is really good. And let me just layer on another piece to this, which is the generative element, right? We all love models able to generate content, not just answer choices. Generation comes into these graphs through the notion that at the end of generating the spreadsheet and going to the boss and all that, the graph would actually have an agent that looks at what it just did and improves itself, right? It says, oh, I'm missing a step here. That would be better to have another review step in here. So it changes what that graph is for the next time. Or maybe it saves what we just did as an example that feeds into the next time because it was really good. It got the thumbs up, right? That's the generative component that's impacting these graphs. I'm gonna share a screenshot here that good. I think is maybe going to add some value here. Let's see. You guys. So this guy basically over here on the left side is kind of where we came from, right? We're all sort of used to the user prompt to an LLM, and we all use GPT, right? And then there's the idea of the loop. And then there's, the idea with tools and of loops with tools and reasoning. This is like the Roth-Wiggum loop, right? And then you get all the way over here into the graph area where not only are we involving some of these loops like we did before, but we also have planning happening. We have verification. As Stu said, there are humans that are in the loop. There's some sub-agent that's being done, right? So one thing that's important in this context to talk about is that I feel like some of these words that we brought in, context and tool and skill, right? They have real world meanings, and they come into the AI world with a kind of a very different sort of a meaning. I don't think that's true for graphs. I think graphs in the AI world mean exactly what they mean in the real world. They're, as Shanti was saying, they're a layout for how things chain together, how they connect, how they flow backwards, how they flow forward. And that's one reason why I think this is a terminal point, meaning graphs are not going to go away in the AI world. It's not like we've abandoned some layers of things that we used to worry a lot about. I think graphs are here to stay because ultimately they let us scale up and down in terms of what we're asking our AIs to do.
Yeah, I say when you think about something like LangChain, which started out as a direct linear chain, what did they create? They created LangGraph because they realized, oh wait, a single linear piece doesn't actually work for this. We need a workflow that could support going backwards, fanning out, spanning parallel agents, or just having multiple processes happening simultaneously, maybe reviewing those processes. And that's like now a SDK for them.
Yeah. Well, and the sort of the tacit implication here that's really interesting is that AI is acting more like people, right? We're having to adapt our AI methodology to be more like what people do, because the AI is acting more like what people do. And so now we need these bigger tools to put this stuff to work, right? To make it yield what we need from it.
I think back to that people analogy as well. I think it, and a lot of things, by the way, loop engineering and graph engineering are not competing frameworks. You're very often going to have loops running inside of this broader framework, which is put together with inside of a graph. There's all sorts of things like that. But I think applying it back to that human idea of I've got a team of people working on a problem. I've got some known division of responsibilities, who's responsible for what, dividing points, standard operating procedures. You have that mode versus, let's go back to the spreadsheet example, right? Versus the single person putting together the spreadsheet. Once you get that team together, there's all sorts of other things have to be thought about now, right? So, and there's reasons, and there's good and bad that comes from this. But if I'm just working on the spreadsheet, I'm putting everything together. I'm going through all of these bits. One, you lose a little bit of auditability and governability around those activities, right? Like I can get in a state of mind, right, around it should work this way, but maybe someone more clear-headed would think it would be in another way. So division of responsibilities helps there. But now when I hand it off, I also have to. You're kind of handing off, like, here's a version and I'm handing it off to someone else, right? And so there's shared state and context that has to be shared between all of these different people participating in this project. And I think when you start thinking about, like, let's say I can accomplish the same goal through a loop, one agent running a long time in a loop versus a series of agents tied together through this graph, it can be an advantage or disadvantage depending on your use case. But one of the things that as you move to the graph, what you've got to do is you've got to have some sort of shared state, some sort of being able to do this. An advantage of that is it does create an audit trail as well, right? Like I'm having to produce things about my work at each step to hand it off. And it creates the way agents work, it creates a little more predictability as well, as I can design on and say, like, hey, I'm always going to go through, there's always going to be these handoffs to these agents at roughly these points to make sure certain things are done, versus if you put it in a loop, it may skip some of those points as long as it's able to kind of check off that it created whatever the exit criteria we created was. So there's just a few things along those lines that I think tie back to Mike's point around, in some ways we're kind of applying the idea of an org chart and standard operating procedures from the human work into this agent design framework.
You could also think about it as who's writing the edges of your graph. If the agent is writing them themselves, you've got a loop. If you're writing, the human is in there creating the edges ahead of time, then you're creating a quote graph instead. If you really want to differentiate those.
Can you explain what you mean by edge, Shanti?
Sure. So graphs have connected points. We call those nodes, and they're connected by edges, the things that you traverse to get from one place to another. And that's usually, in this metaphor, an activity that the agent might do, some information that it might be transferring. So it's doing something at the node, taking that, and then reaching out to the next state that it needs to go to. And that state is going to be that edge.
Just think if you were drawing a workflow, the node would be the circle, or two circles, right? Would be nodes, and the edge would be the line that connects them, right?
Right. And the line represents the data that's moving from one to the other.
Yeah. The other nice thing when you think about how you might want to separate these is if you want to separate the responsibilities of your agent, it's a lot easier to do that in this quote graph framework, because you can have more specialized agents rather than one agent that has to keep all of the context for what is it doing, checking is it done, is it correct, and then just looping within itself, versus I've got a graph that might have an orchestrator. I might have 10 agents that have different capabilities that are each looping within themselves, but I've got one that can have the responsibility of only checking the results of my subagents. Each one of those can also then take minimal context. It only needs the context required to do its specialized job, which tends to lead to better success because you don't have to try to fill its context window with everything that's happened. Here's exactly what you need to do your immediate job. We're not going to give you anything extra, no fluff around it, which should help it be successful.
Yeah, you're saying one advantage of this in the world of graphs, this division of responsibilities, as you're sort of describing it, is that each one then has fresher context. It has a clearer mind about and understanding of the problem and how to solve the problem, is less likely to get confused, more likely to stay on task and to complete the deliverable. Is that what you're saying?
Yeah. I think there's a lot of real practical implications for why you want to think about things that way when it comes to management of multiple agents or agent swarms, being able to understand that they're different, they're doing different things. It's not just one agent with 100 tools. And then you're trying to get into your observability stack and be like, well, which tool did it choose? And why did it make that choice? What was it, my tool definition that got it confused between which of two things it could choose? Or I actually just separate them out and go like, it made a bad decision. Like it called the wrong subagent. That was easy.
Yeah, so it's an interesting one something we've done lately in a couple of our implementations is add what we call an investigator agent, and the investigator's only job is when something goes bad, it has to look at what happened. And what's fascinating is the number of things that it can find that went badly. Right? Obviously, maybe the API provider was down or something simple like that, but also it could be that last Tuesday somebody added an MCP tool, and then on Thursday whoever it was changed the definition of the elements in that thing, and now it broke the agent 1,000 miles away, right? So just the ability to have that investigator in the mix is interesting. So now suppose I previously had what I call an agent, and it was doing a job, and now I've got this investigator that helps me fix that agent when it's broken. Well, now I've got a graph, right? All of that together becomes the graph of how my AI not just operating, which is what the agent does, but it's also continuously improving, which is what the investigator is giving me, right? So you can start to see how all of the AI operations in an enterprise can be in a common graph, right? They can be in that kind of big picture graph that lays it all out. What are the infrastructure pieces? What are the observability pieces? What are the cost control pieces? What are the actual actions, right? Just where that wasn't possible, if you took a sort of an agent's specific or a chatbot specific view of enterprise AI, then you're kind of stuck at that agent level without seeing the big picture.
Is as you were speaking, I thought it feels a little bit more like single player mode or multiplayer mode. Is that I know it's probably not perfect, but is that a reasonable?
I like that a lot. Yeah, no, the analogy is really good, and it can be PvP or PvE, right? You'd be playing against the environment, so everybody but you is an agent, or it could be playing against other people where there are things in the environment that are non-player characters, right? So yeah, the analogy holds really well.
Yeah. Let me throw some stuff I've been working on to you guys, and I'm just trying to see if I make sure I got it. So, for example, an agent might be, so we built a bunch of tools around our own finance close process, end of month close, right? So one thing that it does is we have all these credit card transactions that come in, and the job that it does is it looks at all the credit card transactions, look at the GL codes. It even looks at people's calendars to just see what they were doing to figure out, all right, what's the best classification for this expense? And it runs from top to bottom. Sounds like agent. Or just a simple, and maybe, I don't know if it's even a loop necessarily. It's just a simple agent loop. What do you guys think?
Yeah, so I would call that an agent. And the main reason is because it's going to run from beginning to end.
Yeah.
And it knows when to start, and it stops when it decides to, and that's it. That's all it does.
Okay. Yeah. All right. Now, up a level, I have 9 of these different things. We have, what should be invoice, and, what categorize those expenses, and what does revenue look like? And there's about 9 of these different things that finance does, all is under this close agent, essentially. If I just say, instead of just say, go do the ramp thing, I say, hey, close the month, and it runs each of those.
Right.
Sounds like graph, right?
Yeah.
Is that
Yeah,
what-
and maybe that first one is an orchestrator that calls
yeah.
each of the other ones potentially in sequence, maybe in parallel, depends on
Right.
whether they need the outputs from one to feed into the other.
Yep.
If it doesn't, then that having nice fan out and being able to do them in parallel will be much faster. So you get some nice savings there. They don't need to actually talk to each other. And then you can take that logic of, did I get the finished and correct output from this agent, move that into your orchestrator, and when all of those are complete, it can call a synthesizer and say, great, here's everything you need to now close the month.
I was just going to say, I think that's going to be the next buzz term, by the way. Like you kind of joked about it earlier, Pete, where we went from like prompt engineering to context engineering to harness engineering to loop engineering to graph engineering.
Yeah.
I think orchestration engineering is a good candidate for an upcoming one.
Next, that's your vote.
In a graph is that there is some orchestration between it, but I think as you make that graph bigger and bigger, all of these orchestration challenges really become such a focus on how do you get that right. And
it's almost like the agent is sort of the individual, the graph is maybe the department, and then there's corporate level. There may be other levels actually, depending on.
Well, and this is where it's interesting, and it's sci-fi, but it's also very real, right? I don't know if you guys remember in 2001, The Space Odyssey, when they sent the guy in to fix the computer. He wasn't an engineer. He was a psychologist, right? Because the AI was broken and they needed to find out why. And I don't think we're too far from that. I think there is a point at which this context engineering or graph engineering or process engineering, I mean, it's management. It's like managing people. The humans are augmented by the machines. The machines are doing some of the tasks by themselves. The whole thing has to get laid out and made to work together in a way that's auditable and improved relative to what you could do with either one alone, right?
So how would you summarize the benefits of this approach? Who wants to take a stab?
Actually, that auditability is a nice one. When you need to give something to a compliance officer and you have that graph, it's a lot easier for them to understand what's happening, because then it becomes like an agentic workflow where here are all of the different steps that happen and here's how you get from one step to the other. Like what's it looking for to proceed from step 1 to step 2, versus if it's inside an agentic, like just a single agent loop, right? We asked the model to keep going until it got to where it needed to go.
And it did.
It got there. We think.
Yeah, and it's saying the same thing in another thing. It's auditability and predictability as well, right? Like with these agents, when you give them a task, give the same task to Claude Code 5 different times, right? It may reach the same result, but do it 5 different ways, right? And that's kind of, and there's still going to be that inside of each circle in the node, right?
Yeah.
But there's more predictability in the lines, if that makes sense.
Well, and it sounds like because you're isolating the job, of that agent, that agent itself should be much more reliable.
Yeah.
Right.
Yeah, I mean, especially if you could sandbox it, right? Really, agents like following the OpenClaw standard and the sort of agents that can write their own content, they're almost like the Marines, right? They just, whatever you got, give them the job, they're going to go get it done, right? But you still need the general telling you where to send them.
Yeah, where to go.
Otherwise, you could have a lot of stuff going on in a lot of places, right? And so that's really where these benefits come in. And it's interesting because so many of we've been amazed by all the work that the AIs can do, but now that we're getting into the harder, thornier problems, we're getting into the greater needs. And so, a simple example, like if you were designing a new employee onboarding, right? You've got to get their business cards printed. You've got to make sure somebody greets them at the door, make sure they go through training, get their I-9 filled out, make sure they're in pay, all those things, right? A lot of those are going to involve a human, maybe verifying documents or a human approving a payroll step. So you can't just say, well, run the agent until it's all done. The agent has to run and go to sleep and wait for an event and then come back alive again. That's not something that an agent by itself does. That's a graph, right? So this graph capability, you might have other cases where you have, within one organization, you have agents need to run in a factory, agents need to run in a data center. And the results of those two need to get brought together. Again, it's a graph. The agents are going to be in one of those places at a time, not in all those places. And they can only sort of reach out and control just to a limited extent. So just the idea that We can have these long-running processes that are curated over time, where the process itself is changing and the results are being checked, right? That's the richness that you get out of a graph capability.
I was just gonna say, I didn't hear anybody talk about speed, and if I did, I missed it. Is that a benefit or no?
To the extent that you get repeatability, right? A lot of times repeatability comes from agents through iteration. Which then slows things down. So to the extent that a graph is there to say, no, we have a specific way that we know how to do this particular task. That's not an agent. We have this other task that's a little bit more unknown. Let's figure out how to do that part, right?
Yeah.
That's definitely an improvement you can get from graphs. The other thing with a that's important when you're assessing the performance of the AI is how much did it cost and how long did it take?
I was just going to come to that. This sounds expensive.
Right. Yeah. Well, I think the reality is, in a graph scenario, because it is better defined, you can put a price tag on it. You can say, what is it going to cost to build this? Whereas if you just hand it all to an agent and say, go nuts, right? You don't know how long it's going to take. You don't know what budget it's going to have and the quality of the result that's going to come out, right? So by making those, leave the pieces that need agency in an agent box, but make that box as small as you can. Put those boxes together with a graph that gives you the predictability, the cost control, the reliability, and the testability.
What makes the cost more predictable in that example?
Yeah. So think of it as, if you have a task that an agent's going to be asked to do, and 9 times out of 10, it's going to do it consistently the same way. But that 10th time, it's going to go wrong and repeat the task. Well, if you already know how you want it to do the job, don't make an agent do it, because then you're going to have a 10% cost overrun, right? Instead, do it in a way that's prescribed, and that's going to lower your cost. And that effect compounds, because we're not talking about one agent, we're talking about 100 agents that are in these systems, and there'll be massive increases in the cost and the time that comes through. You either have to accept unreliable outputs, or you have to accept higher cost. If you want to just stick to that sort of hands-off approach, let the agent do it, you put it into a graph, and now it's well defined, the sequence of steps that it's going to go through, the points at which you can measure inside that process, the dashboards that you can get out of it, right? That's what makes it confinable. You can measure it, therefore you can confine it.
I would imagine, though, there's plenty of scenarios, like when you're fanning things out, for example, to have multiple agents do something at the same time, you could significantly drive your expense up.
So I think you would drive your expense up if you didn't need to run those all at once, but you chose to for speed. But if you need to run them all, you just run them. For
context clarity, maybe.
Yeah. So if to me, it always comes down to, the first thing you have to do is get the job done. And then you can start optimizing, right? So once you can prove that the system is capable of the job, now you can start saying, all right, what's extra? What's being repeated? Where are the efficiency points, right? Where can I probe, right? It's always my favorite is when, you see somebody who's running wires maybe for the speakers or something, and they tie it all down perfectly, and then it doesn't work, right? Now, run the wires first, make it play some cool music, and then tie it down, right? Then tighten it up. So same thing here. Prove that it can do the job, right? And then once you've proven that it can do the job, now you can go, and it's called perturbation theory, right? You change one thing at a time, right? Change the model to a cheaper one. Did that fix it? Did that make it cheaper or not, right? Because sometimes a cheaper model runs longer, right? So change JSON to YAML, whatever the things are that you could do. Change one thing at a time to drive that cost down, and you use regression to never lose the functionality that you've got.
Yeah. Any guidelines you guys would offer, like when agent, when graph, when, and obviously there's some variations here, but any rules of the road you would sort of offer to folks?
I think if you look at the complexity of the job, would it benefit from parallelism or not? Like, if it's not going to benefit from parallelism, if it's not that complex, you don't need to bother with the graph potentially. But it doesn't really hurt to start thinking with that framework, because if you think about everything that way, some things are just simpler graphs than other things. So if you had to just pick a method of thinking about problems, it's not a bad way to think about.
Mm-hmm. Yeah, I would say an easy one for me is if one human is going to do something and wait for it to finish, that's probably an agent. Maybe even just a loop, maybe even just a prompt, right? If many possible humans need to do something and many possible agents could be involved, that's probably a graph, right? If it's a multi-day, if it's a long-lasting thing that I need done, but I'm not waiting for, then it's going to be more like a graph.
Graph is a little bit of a confusing term. If you say flow chart,
I know. That's what I look at. I'm like, well, let's go flow chart.
I'm building a Visio diagram of this this process that I'm trying to flow. I think if it's simple enough that you feel like that's not really a flow chart so much, right? It's just a checklist. That's really, I think, when you go more to just the single agent, when you start to think about, well, how is this getting done, regardless of who gets it done or how you start to want to break that down into a flow chart. I think that's when you need to start thinking about, like, well, should I just a graph is just basically encoding that flow chart into what you've engineered. So I think that's kind of the way of thinking about it.
Makes sense.
Yeah, I mean, as Stu was saying that, in my brain, I was thinking about, a power source. Let's say I want a power source. Great. Here's your Duracell AA battery, right? Well, no, but I need, triple redundancy and hundreds of thousands of watts and distributed anywhere. Okay, well, I'm like another power source, right? The first one is a very simple power source. The second one is much more complex. They're both doing the same thing at the end of the day as far as the micro level action of the result, but clearly one is a much bigger job and needs a much bigger definition. And to me, the ultimate thing that proves something is a graph is when it needs to correct itself, when it needs to observe its results and make changes for next time. Which again draws me back to that's like humans. It's the performance review cycle, that comes. It's the organizational transformation cycle that we go through.
I like that you went there, because I could envision some people listening to this and go, well, wait a minute. Sounds like an org chart. Sounds like replacing me. Like, what? Help me understand that. And how do humans relate to this new org chart, if you will?
Look, it's been said many times that AI won't replace people, but people that use AI will replace people, and I think that continues to be true. The AI by itself is a bulk tool to handle a lot of things, and humans that wield it well, and it's bidirectional, by the way. Humans teach the AI, and the AI teaches the humans, and when that works synergistically, you get superhuman performance that is, supercharging companies. But one opinion that I have on that space is that it doesn't create a need for fewer humans. In fact, I think it creates a need for more human labor, because, well, think of it as, if let's say a very specialized skill set was needed to do a certain task, you would be limited to how much of that task you could do by the specialized skills. Now imagine that anybody could do that task if they have AI helping. Well, you're going to have a lot more bandwidth to do that task. And now a lot more people are going to want that task done, right? Whether it's a specific kind of writing, whether it's a specific kind, of tax advice or legal advice, all kinds of things, right? That product design. I mean, there's just a lot of activities where people augmented by AI, like programming is a great example. There are more people programming than ever because more people can do it now. Does it mean that we need fewer programmers? Probably not. It just means we have more software, right? That's the way this, I mean, if we had the marginal value of an additional accounting clerk in an average corporation, right, is whatever that is, and we live in this sort of constant tension of too much work and people burning out versus what the business needs, and we just find a kind of a minimum that everybody can agree on. Well, if each accounting clerk can do a lot more, you're going to want more accounting clerks, not fewer. Because because every one that you add is more valuable to you until you saturate, until you get the job done. But we haven't found that, and in a lot of job functions, we haven't found.
Yeah, it is interesting. Stu, you sent something out. I don't remember the name of the article or what it was called, but it had some really interesting examples of, there's a cook. There's cook A and chef A and chef B. Chef A just follows the recipe top to bottom and does the thing. Chef B realizes that, the oven's running too hot. I need to make this change, or the olive oil was not what I wanted, or I ran out, so now I have to improvise, and so on. And they're both going to end up in a very, very different place. Well, because one just followed the recipe, and one was actually connected to reality and was able to sort of adjust on the fly. I feel like, in just my own working with agents, I just feel like that doesn't go away. Like, the business is constantly changing. We have new products. There's a new pricing model. There's a new, so I just think it becomes more and more, and it takes away from the work that's happening. Like, so who wants to sit and categorize 300 receipts and what GL code they belong to? Like, nobody. So I'm with you, Mike. I think very much requires a lot more human. I think it's more engaging, more interesting work.
Yeah, I think this is all a little theoretical in our heads a year or two ago, and we didn't know how it would go. But I think that with more time that goes, the better we get at, the better AI gets at software engineering, the more engineering people want in the world, and the more humans it takes to drive that.
There's
and
no
I think
doubt.
it's happening through a lot of other domains. It's kind of like,
Yeah, I think that's where we'll also see the benefit of when Hermes Agent came out, it started introducing the idea of self-improving skills. Like it'll do it once, ask you how it did, or try to evaluate its success, and then take the corrections into account, rewrite the skill with those things in there, and do it again, so that every time you actually use the agents and they call the tools, each of those components can get a little bit better. Because the hardest thing to do, right, is write true automated evals to understand. Some of the things are difficult to evaluate. But if we can have humans doing that and say like, yeah, this is pretty good, but even implicitly, because if their follow-up is do it again, or do it again, but do this, you don't even have to ask. You now know it wasn't that good, and you can go and improve that skill once you get to that final result where the humans accepted it, and our AI gets more powerful, and we can start thinking about the next set of problems and how we want to structure those, how we want to set them up, as opposed to trying to think about the mechanics of the problems and what is it going to look like to do this.
Okay.
That's right.
Yeah, I agree. Final question, and give you guys each your final word on. So, but based on this entire topic, what are some of the thoughts you might just want to keep, one or two things to keep top of mind for executives that might be listening to this? Shanti, why don't we go Shanti, Stew, Mike?
Yeah, I think graphs are a really useful way for thinking about problems, thinking about the solution to your problem. They're very visual, which makes it easy for architects to build and understand and explain them to lots of different people. You can see what's happening, and that observability makes it easier to maintain these things in production.
I think you're just seeing, as we build up this long chain of buzzwords from prompt engineering to context engineering to harness engineering, yada, yada, all the way down to graph engineering. I think you're just, the meta thing is agents are getting more capable. And as they get more capable, we're able to obviously give more and more to them. But that is its own level of architecture and engineering, right? That's having to grow up and mirror a lot of human constructs over time. But I think the big takeaway is we can build so much more sophisticated things today than we realistically could have a year ago. Enormously more than 2 years ago. And I think this is just the next phase of that evolution. And it's really starting to get real now, in terms of how effective these tools can be.
Yeah, we're beyond help me craft my email to help me just close the books for the month.
Yeah, exactly.
Sure.
And which takes me to what I would be talking about to people that are making important decisions that need to lean into this. And that is to focus on this new animal in the zoo called the sandbox, right? So these agents, as they get more powerful, you're going to want to give them more freedom, let them do more things on their own. But to do that, you also have to restrain them from doing things that they shouldn't do, right? So the answer is a sandbox. And it's an IT concept, like a server, like a Docker image, lots of concepts that are familiar. But it's just a place where an agent can live and work and do its job, right? And it's famously the Mac Mini craze around OpenClaw was basically just creating a bunch of sandboxes.
A physical sandbox.
A physical sandbox where things could run. So if you're an IT executive, right now you should be thinking about, how do I ramp up my sandbox strategy? Because I'm going to want those agents to be super powerful. I need to know, who's my vendor for that, and the other interesting thing that you're going to want to figure out is cloud managed agents, right? So the idea of having it do dangerous things in a box is one thing. Dangerous things, I mean, like deleting files and things like that.
Yeah. Giving it permission to do what it wants.
Yeah. Right, exactly right. Giving it, instead of having a human say, yes, you may change to that directory every time, just put it in a box and let it do it and get the result out, right? So that's one piece. But then how much of the software lives up there? That's where we get into cloud managed agents. And that's where agents become a service of their own rather than being a software that you run that uses the APIs, which are a service. So I think those are the two IT things to think about. On the business side for enterprise customers, I'm going to lean into what I've said drumbeat forever, which is the evergreen. The evergreen story in AI is capture your business processes. And when I say capture, that sometimes people get lost in what that means. I mean, write it down. Just write down what you do. At the end of the month, I fill in the blank. Write it down on a notepad and scan it in. Right, make a videotape of yourself talking about what you do when you have a difficult customer situation. Capture every one of those stories that you possibly can and do that across your enterprise, because that's what's going to turn into the gold that makes your AI better than your competitor's AI, right? And it doesn't have to be this massive organizational level hierarchy of approval processes to define the standards. You'll never get there if you do that. Instead, get your best people to write down what they do, and the AI will be able to repeat that and help them. And that's how the fire spreads.
Awesome. Well, gentlemen, thank you very much. Great to see you. Awesome episode. And we'll see you guys on the flip side.
Sounds good.
Bye all.
See ya.